Okay, hello all. Welcome to HRU. This is our 24th year at doing Ham Radio University. The past 3 years we've been doing virtual meetings because of COVID. And we hope maybe next year to go to either a hybrid type of a mode or strictly in-person brick and mortar again. If you can hear me, you can disregard this slide. But if you're not getting audio, this is for people that aren't getting audio. In the past couple of years, we've seen a lot of text that came up that said no audio and not getting audio. And if that's the case, this is a lot better than trying to troubleshoot your computer. So I'll leave this screen up for just a second or two, and then we'll move forward. Okay, so hopefully people will get their audio. I'd like to, you're probably going to see this slide or something similar to this throughout the day. Phil Lewis, the N2MUN, was the founder and kind of the creator of Ham Radio University. Back in 1999, he approached various club presidents, including myself, said, I'd like to get a bunch of guys together and set up a set of forums and seminars. Started out as reaching out to maybe some hams that have been in the hobby for a while that maybe were licensed a number of years ago, got out of the hobby because of other priorities like raising a family, whatever else. Now they have a little more time on their hands. They're back into ham radio, and it's changed in the past 20 years, and was really meant to kind of get people back reacquainted and get them a little more up to date. And over the years, we've gotten a lot of new licensees that, okay, I have a ham ticket now what? So we started aiming some forums at those kind of folks. So Phil has always been, I used to call him Uncle Phil because he was always like everybody's favorite uncle. He's just a sweetheart mensch of a guy. Unfortunately, he passed away in 2020, and we all miss him dearly. All right, so here's my pitch on ham radio. Your license allows you to do a lot more than just operate a radio. You're allowed to build, maintain, operate, modify your radios and your own equipment, and that's kind of unique to ham radio. And this forum is focused on getting your first HF station on the air. And HF station is not just a radio, it's a system. So you've got the radio, you got the antenna, you got the feed line going from the radio to the antenna, all the accessories that interface with it. Just virtually everybody that's on HF almost nowadays has a computer integrated into their station in some way, shape, or form. So we'll talk a little bit about that, and everything from like the basic room where you're going to set up and the desk that you're putting the equipment on. It's all part of the system. So before we get started, I'd like to do a poll. And I think Pete will set it up. It's basically, how long have you been a licensed ham? So Pete is going to set that up. Pete is my organizer behind the scenes. And we'll leave the poll up on the screen. We'll give you a minute or two to respond, and then we'll close up the poll and have Pete let you guys know what the results of the poll are. I'd be curious to see how many old hands there are and how many newbies there are that have never been on HF. Give it another 30 seconds, and then we'll see. Pete can tell us how many people have percentage of the people who have responded, and how many people gave us each answer.
Okay, how did we do, Pete?
Well, good job, attendees. You're awake this early morning. Here are the results. 2% are unlicensed, 21% less than 1 year, 26% to 5 years, 13% 6 to 10 years, and 38% more than 10 years. Those are the results.
Okay, well, I'm probably going to be talking to a number of people who probably know more than I do about this, but let's get started. Okay, so before you really start to build your station, there's a few questions you got to kind of answer for yourself and think, you know, what are your interests? What are you looking to do with your HF station? What are your favorite? What modes are you interested in? You know, you just want to use voice? Do you want to use digital modes like FT8? Are you interested in Morse code? And I know a lot of people are, because the Morse code forum has the highest number of registrants for today's forums, and that's a lot of fun. You interested in DXing, just seeing how many countries around the world you can work? Do you want to be competitive in contests, see how many, you know, get into that? There's a lot of competitions throughout the year. You just want to make contacts, talk to people. You want to experiment? You want to build radios? Do you want to buy radios and try different antennas? So some things to think about. Another factor is time invested in the hobby. How much time do you really have? Are you going to be operating mostly during the day, or are you a working stiff like me, where you're only going to be really, where the majority of your time other than weekends is going to be evenings? That might affect what bands you want to operate on. Some bands work better at night, some bands work better during the day. That may modulate what bands you want to focus on with your antennas. You want to look at your budget. You know, you might think the radio is the biggest piece of it. Not necessarily the case, especially when you start getting serious about DXing and contesting, and you want to have a really good signal. The antenna is really the what's going to determine how well your station works. So, you know, good rule of thumb, maybe not when you first get on the air, maybe not half of your investment is in the antenna, but later on it may be if you start getting interested in putting up towers and beams and things like that. But you know, good rule of thumb, half of your investment is going to be in the antennas, you know, then a quarter on the radio and another quarter on various accessories. Just a piece of feed line the feed line that goes from the radio to the antenna. A good piece of coax, the price of coax is in terms of dollars per foot. So you may spend $100 just on cable to get from the radio to the antenna. Your shack location, antenna location, you got to think about what town restrictions there are. If you're putting up a tower, do you need a permit? A lot of you have a family you've got to live with, and they all have to live with whatever you put up. And if the wife doesn't want that ugly antenna on your back lawn, you might have to compromise for something a little less unsightly to the little lady, to your spouse, your significant other. Feed line cabling, again, one of your challenges is that the antenna is outside, the radio's inside, so you got to get a piece of cable into the house. And how are we going to do that? Choosing a radio, we're going to take a look at a few different options for radios. There's lots and lots of options. I'll take some of the more popular ones that I've seen. But you know, when it comes to choosing a radio, a lot of it is like a Ford versus Chevy kind of a decision. But you know, one way is to, you know, try to talk to other hams that you know, mentors. If you're a member of a club, talk to some other club members, see what they have. There's a website called eham.net where you can see reviews on various radios. When you look at that, I would say the people that give a particular rig a 1 or a 5
are the ones you are probably the least informative. The 2s, the 3s, and the 4s are the ones where people really put some thought into what they say. So you can look at what people think of the particular rig, if the rig has a particular problem, or if everybody loves that radio. As I said, almost everybody on HF uses a computer with the radio, so you're going to want to have a PC, and there's interface boxes that go between the computer and the radio. And then there's other extras like test equipment, headphones, keyers. A lot of the smaller radios require an external power supply. So we'll try and launch into some of the things you're going to need to set up your station. So as a starting point, where am I going to set my radio up? You don't want to be in the middle of the living room, obviously. You want to be someplace where there's not a lot of traffic in the house, where people aren't going to be kind of coming and going. You want to set up in a room where you can set up a desk that's big enough, not only for the radio, but for a computer, probably 2 monitors, a place where you can rest your entire forearm on the desk if you're operating CW, so that your arm is rested when you're using the key for ergonomics. You're going to want plenty of outlets. 2 sets of 410 volt outlets is a good starting point. You don't want to be, plugging power strips into power strips into power strips. You want to have, some decent AC wiring. At some point, you may consider a high power amplifier, like a legal limit amplifier, and a lot of the bigger ones need 220 volts. So at some point, you're going to need 220 volt outlet in the room. And I'm showing an example of a feed through that MFJ makes that mounts in a window, and they make it wide enough that you cut it down to the width of your window, and you close the window down on it. And it's a way of getting some of your coaxes from outside the house inside the house, because as I said, that's going to be one of your challenges. How do I get the coax in? Do I drill a hole through the the base plate of the house? Do I try to come in through a window? What do I do? Through a vent upstairs in the attic? Okay, by the way, this presentation was originally set up by Phil N2MUN. He did this presentation for years, and I took it and I tweaked it a little bit, but I'm trying to follow his format as much as I can. You've got some choices on antennas. If you're brand spanking new to HF, you're probably going to want to start out with some kind of a simple wire antenna. They're cheap. You can build a dipole antenna mostly with materials you can get at a local Lowe's or a Home Depot. Just wire. You can make up some insulators and stuff. And I'm going to be doing a forum at the end of the day on some practical antennas. Most of it is wire antennas you can build. You do need a support structures, but wire antennas, your support structures are usually existing supports that Mother Nature provides, namely trees, maybe the roof of your house or whatever. Depending on how much property you have, you may want to consider a vertical, because a vertical antenna doesn't need as much of a footprint on the ground, and a vertical doesn't have to be way up in the air to work. You can mount a vertical on the ground and it'll play. It's got a downside, is that it's omnidirectional. It works equally poorly in all directions, and verticals tend to be more susceptible to picking up man-made noise, ignition noise from cars and air conditioning motors and things like that. But that's something you can get up. It'll get you on HF. The next level up, when you're ready to really get a little more serious, once you know that HF is for you and you really want to do this, you might want to consider a beam antenna. It's a large rotatable antenna that works better in one particular direction than another. So number one, your effective output power is higher in the direction the beam's pointed. Your receive, you're going to be able to hear better in that direction, and at the same time, you'll be less prone to interference from stations and other sources that are not in the direction you have the beam pointed. But a beam, you're going to need some kind of a sophisticated support structure like a tower, maybe a tripod on your roof. So this, you've got the antenna and you got the support for it. And if you're putting a tower up on the property, you know, just to get a base port, you might be, you know, you're going to be investing money just in the base, much less the tower itself. And then you need a rotator in the antenna itself. So a beam is a little bit more of an investment. So these are kind of your antenna options. Radios, the top three radios I'm showing here, the upper three are kind of low cost starter radios. You can, they you know, they work well. They'll get you on the air. The ICOM 718, that's a nice, it's a low cost, easy to operate radio. Kenwood 480 and the Yaesu 891, they're really set up more for portable and mobile, but they'll work in your shack. And that's something you might buy as a starter radio, and then later on, if you decide to upgrade, either sell it or keep it as a backup rig. And then down below are the middle range radios. I really don't want to start talking about radios that go for like $10,000. You don't want to really spend that kind of money on your first rig. But these rigs, the TS590, the ICOM 7300, and the new Yaesu radio that just came out, the FTDX10, is it's a rig a lot of people are getting excited about. And these radios are in about the $1,500 to $1,800 price range, and they really fantastic radios. If you want to go used, there's some radios here that are a bit dated, but they're still great performing radios that you can probably pick up for around a grand. If you can find a FT1000D, that's like the king of, when it came out, it was the king of radios, and they still play pretty well. And the nice thing about these bigger radios is they bring all the controls to the front panel. You don't have to hunt for controls via a bunch of menus. If you're going to invest that kind of money in a used radio, I would suggest only doing that if you know the person that's selling you the rig, not a total stranger on eBay, or have somebody that you trust and know that can come with you and check the rig out, just like when you're buying a used car, have a mechanic look at it, have somebody look at it. But these three rigs are all really good high-end radios that were hot stuff 10, 15 years ago, and they're far from obsolete. They'll play good, and you'll do good with them. Okay, most of you, if you're going to start out with wire antennas and use them on multi-bands, you're going to need some kind of a tuner to match the antenna to the radio. I'm showing two tuners here. There's the 300-watt tuner above. That's a handy tuner if you're going to be going portable and operating, because it's lightweight and it's a little bit cheaper. I would recommend, though, for your main shack, going with the larger tuner, even if you're not going to run 1500 watts. That tuner has got larger and less lossy components in it, so it's going to do a better job getting your power out to the antenna rather than just heating up the internal components of the tuner. And when you set up a manual tuner, what you're going to want to do for each antenna that you have, and you're probably going to eventually have more than one antenna, for every band you operate on, you want to, once you get the thing set up the way you want it, it takes a little practice to tune an antenna. You're going to want to take the transmitter, antenna, and inductance settings and write them down and document them for every band you're on, so that when you go back to that band, you can get there or get close to there fairly quickly. And also, if something happens to the antenna and all of a sudden it takes a radical difference to get the antenna to tune, you know, you have an indication as to the health of the antenna. They do make automated tuners where you just hit a button. In fact, a lot of these radios have tuners built in. They're nice and convenient. You hit a button and zap, you know, the antenna's tuned. But they do have a couple of downsides. Number one, the manual tuners tend to have a little bit more range than an automated tuner. They'll tune in antennas that the automated tuner won't. And number two, if it's just a one button, push the button and you're all set, don't worry your pretty little head about it. A lot of information about the health of your antenna and your coax gets hidden from you. Whereas with a manual tuner, if there's a large, you know, if you have to suddenly tune it differently than what you have written down in your list, it's time to go back and take a look at your feed line and your antenna and see if something might be wrong, maybe a you know, wire broke or something or whatever. So I prefer manual tuners, or better yet, have antennas that are resonant antennas that are matched without even needing a tuner. Feed line is an integral component of your station. It's got an important job. It gets the signal from your transmitter to the antenna, which is not a trivial task. So here's some different kinds of cable. LMR 400 is a little bit higher end and usually more for VHF than HF. You don't really, this RG 213 cable is probably good enough for HF. If you're not running a lot of power and you don't have a really long run, you can use RG8X or RG8 Mini, which is a smaller diameter. It's about a 1/4 inch diameter, whereas the other two here are almost a 1/2 inch. And as I said, you got to price this stuff out. And you know, some of this cable, like LMR 400, it's you know, you're talking about dollars per foot. So a 100-foot run from your shack to the antenna, you're talking about, you know, maybe $100 to $200 worth of coax. But it's money well spent because it gets the power from the radio to the antenna more efficiently, and your station will be more effective. Chances are, if you're going to get serious about HF at all, you're going to have more than one antenna. You're probably going to have something for like 20 meters through 10, and then other antennas for 80 meters, 40 meters, 30 meters. You're probably going to have at least 2 antennas. So you're going to want to have switches. And also, if you have more than one radio, these switches work the other way, where you can take one antenna and decide which radio to connect it to. And there's a couple different manufacturers. You can get stuff from MFJ. There's a company called Alpha Delta, which their stuff is a little bit better built. When you look at this, if you look at the switch carefully, there's a middle position that's like a ground position. And that's something like if there's a thunderstorm coming in, you can just throw the switch into that position and it grounds out the antennas and gives you somewhat of a degree of lightning protection for your radio. On the lower right, there's I'm showing an outdoor, a remote antenna switch and a control box inside the house. A little bit more of a solution towards minimizing the number of cables that are going from outside of the house to inside the house. You can throw the switch remotely, and it may cut down on the amount of coax that you use. That $2 a foot cable that gets your signal from the transmitter to the antenna. So a few ideas for some basic antennas, and there's going to be more on antennas later on in the day. This is just a basic random antenna with 450 ohm ladder line going into the tuner. And this is something where you get as much wire out there as you can and as high as you can get it. Ideally, you want this to be at least a half wave on the lowest band you're going to operate on. So if you want to go on 80 meters, ideally you'd like this antenna end to end to be about 128 feet long, 64 feet on each side. If you can't get that much, if you don't have trees that are that far apart, or if your property won't allow it, you do what you can. But a random thing like this, and with a tuner, you can get this antenna to work on every band. Another option you have is a resonant dipole, where you cut the antenna to the right length for the band that you're on, and it's tuned kind of like a guitar string. So you've got this equation that everybody that passed a license test had to memorize, 468 over the frequency. It's a magic number. And that's a kind of a starting point to get you an antenna that'll work with your radio without a tuner. It'll have a low SWR, like a 1-to-1, 1.5-to-1, whatever, without the aid of a tuner, and that will that'll outperform a random antenna that you have to tune with a tuner, generally speaking, particularly if you're feeding it with coax like this. This is here's an idea for an antenna that if you want to get on 40, 80, and 160 meters, 160 meter dipole using the equation that I showed you in the last slide would be a 256 foot long antenna. Not everybody, most people on Long Island don't have room for a full size 160 meter dipole. Barely have room for one for 80. But this is a setup here, the entire length of this antenna. They give you these lengths in meters. If you convert those to feet, the entire length of that antenna end to end is about 82 feet. And there's a couple of traps in there that allow you to use the radio on different bands. What the 40 meter trap does is when you're on 40, it essentially isolates everything to the right of that trap, gets isolated away, and only the part of the wire from the junction box up to the trap works on 40. Then when you go on 80, the section up to the 80 meter trap is incorporated also, and the 40 meter trap actually takes all that and electrically lengthens it, so you have a setup that's the right length for 80 meters. And similarly for 160 meters, both of the traps let RF through, and they electrically lengthen this 82 foot section to roughly 128 feet, which is half of a 160 meter dipole. And then the other half is basically the ground. And there's some more detailed instructions available here on how to build the traps. And incidentally, you don't have to take notes. This presentation in its entirety is going to be available on the Radio Central Amateur Radio Club website, and we'll have that at the end. We'll have a slide that shows where that is. Let's see how we're doing on time here. Over. This is another way of making up a wire antenna that'll work on multiple bands. The idea of a fan dipole is you have a bunch of dipoles, one for each band, using that ubiquitous 468 over F equation, and just tying them all together at the feed point.
And what happens is on the band that you're operating on, let's say, for example, on 40 meters, what'll happen is all the other sections that are for the other bands present an open circuit at the feed point. They're higher impedance, and the band that you're on shows a 50 ohm load. So it kind of automatically switches to the section of wire for the band that you're on. So that's another technique of a wire antenna that'll work on every band. There's another option is a long wire antenna. So this antenna will work. Again, it requires a tuner. It's not a resonant antenna, but you just get as much wire as you can out there, as high as you can, and you tune it, and it'll be effective. A lot of people use these. Higher is better, and longer is better. Wait a second here for the train to stop. Another consideration here is station grounding, and the next seminar or forum after us is a whole hour forum just dedicated to grounding. But what you want to do is you'll find that each accessory in your shack, your rig, your tuner, your watt meter if you have one, they all have ground lugs on them. And what you want to do is tie them all to one common point. You can see a common point right here where everything's tied as a star ground. And that affords you some degree of lightning protection. It keeps all the chassis at the same potential, which was way more important back in the days of tube radios where there were higher voltages and a chassis could develop a voltage. But it's still important to have all the chassis in the shack on one at one common potential. If you plan to put up a beam antenna, you're going to need a way to support it. So here's some of the manufacturers of towers: Roan, US Tower, Universal. You have another option of putting up. There's hip towers that'll go on the roof, tripods. The beam on the right, there's a what they call a hex beam, which is basically fiberglass spreaders and wires, and the whole business being rotatable and directional. And you can put that on they make like mini towers, tripods that'll go on your roof. The rotators, I guess Yaesu and high gain are the two most prevalent sources of rotators. The high gain rotators are a little less spendy. It's getting harder to find parts for those. If you're going to have to rebuild a rotator, then it'll last forever. But the Yaesu rotors are a little bit newer, a little bit nicer control box, but they'll both turn your beam and rotate it in the direction you want to go in. Okay, test equipment. You're going to want to have some stuff in the shack to understand the overall health of your station. On the top left, we have a couple of different antenna analyzers that'll tell you not only the SWR of your antenna and feed line, but you can do things like if you have a chunk of coax, you can measure the loss of the coax. And the way that works is you connect one end to your analyzer, the other end you put a short on it, and the meter has a mode where it'll look at, it'll shoot RF down the coax and see how much gets reflected back. A short circuit should reflect all of the power back to the analyzer, and if the cable has loss, then it'll know how much power didn't make it back, and it'll tell you something about the health of the coax. This MFJ thing has been around for years and years. You can still get them, and
You can tune them anywhere from the bottom of the 160 meter band up to 2 meters, and I think this particular one has a UHF mode where you can look at a 450, a 70 centimeter antenna and see how that is. Rig Expert came out with something that's a little bit more up to date, a little bit things done digitally where the MFJ was analog, and it's got a little more intelligence in it. It'll sit there and set up a plot for you, so it'll plot your SWR over the band, see where the minimum is and what it is at the band edges. So it'll give you some information on the health of the antenna. So if you're gonna homebrew a wire antenna or set up an antenna where you got to make adjustments, these things are handy. What I don't have on here is a watt meter. If you're going to have an antenna tuner, the 2 tuners I showed you in previous slides have watt meters built in. So you may want to have something like that to see if the health of your transmitter, is it putting out the 100 watts that it's supposed to be. And when you're running tests like that to just evaluate your station, you're going to want to have a dummy load. And what that does is it allows you to transmit with the transmitter without going out into an antenna over the air. So every ham should have a dummy load that they can use if they want to just run some tests on the transmitter without going on the air. And some basic things like a multimeter. For 90% of the stuff you're using a multimeter for in the shack, an El Cheapo Harbor Freight $5 meter will do the trick for you, but you can also go for higher end stuff. Just for things like, if you have a battery, a lead acid battery to run a portable system, how much charge is on the battery. Checking out your interconnect cables. Do you have a short in your coax? The meter will tell you that. Simple things like that. And on the other side here, some people prefer to use crimp connectors instead of solder connectors on the end of their cables. There's kits for that. So a few things to think about in terms of test equipment. As I said before, just about everybody that operates a computer becomes an integral part of your HF station. And here's some various interface boxes that'll go between the computer and the radio. A lot of the digital modes, 30 years ago, you'd buy a $300 box that would get you on one particular mode like RTTY or packet radio. And then if a new mode came out, you bought another $300 box or you'd upgrade. Nowadays, a lot of the digital stuff, the computer does the heavy lifting, and the computer and the sound card in the computer do all that work, and you get everything from radio teletype or RTTY, slow scan TV, FT8, which is one of the more popular current modes. And what these sound card interfaces do is they take care of the problem of getting audio to and from the radio from the computer. They deal with the differences in impedance and voltage characteristics from the sound card to what the radio requires at the mic connector and what comes out of the earphone jack of your radio into your computer. I tend to like the interfaces that have level controls and knobs on the front panel. They're a little easier to deal with than trying to do that through menus in the computer. The one at the bottom, this Micro Keyer 3, that's a little bit higher end. If you're going to start getting into serious contesting and DXing, that's a ways down the road if you're just getting started. The Signal Link and the Rig Blaster Advantage, each of those are somewhere in the $100, $150 price range. And this Micro Keyer is about a $500 piece. And it's got some features you probably don't need right off. Some other accessories here. You're going to want to have, if you're going to operate a phone at all, or you're going to want a headset with a boom mic. If you're operating CW, one of the advantages of that is at night, you're not yapping into the mic and waking up the whole house, but you're still going to want a pair of headphones. You're going to hear more stuff with headphones than with a speaker. If you're going to start contesting or DXing, where you're going to lose your voice after a while, this voice keyer is basically just a digital version of a tape recorder, where you can have different messages like a CQ or whatever, and record them and have buttons to play them back. I included some different power supply options here. If you're going to get a lot of the HF rigs that you buy, all but the biggest, heaviest radios require 12-volt power. They don't just plug into the wall. So you need a power supply that'll get you from AC down to 12-volt DC to run your radio, and supply enough current that when you key the radio, the supply is giving you adequate current. And there's power supplies fall into two basic flavors. There's linear and there's switch. Ooh, 5 minutes? Okay, we're running out of time here. But the linear power supplies tend to be a little bit heavier physically. The switchers are lighter weight. What they do is they increase the frequency from 60 hertz to a higher frequency, so that the transformers are lighter in weight. The disadvantage is they might put out some birdies that you'll hear in the radio, but with the current technology, they're pretty good. And like I said, they don't weigh as much. You don't have to be a muscle man to pick it up and put it on the table. We'll try and wrap things up quickly here. You set up your station. This is an example of a fairly complicated station. Once you're set up, you want to take some pictures, draw schematics and block diagrams of what goes where, label your cables, because at some point you're going to have to take something apart. You're going to have to remember how it goes back together. Have copies of all your manuals handy. When you're using a computer, a lot of these programs, it takes a while to get them set up the way you want. Once they are, you go through all the settings screens that are involved and take screenshots of them and get them printed out somewhere. So if your computer crashes, or if you have to install the program on a new computer and reset it up, you know where everything was. Your antenna SWR data, you'd like to know what it is with and without the tuner for every band that you operate on. And also when you're using a tuner, what your tuner settings were to get the antenna to work. Continuous on the air performance, a lot of DXing and contesting. The guy at the other end just gives everybody a 5.9, which is perfectly readable, extremely strong. And if you want to know how you're doing, you really got to talk to people and say, what's my actual signals? How am I doing? How's my audio? Possible improvements. An antenna is a good place to upgrade. Bigger is better, higher is better, as a rule of thumb. And more efficient feed lines, especially if you have a long run from the house to the antenna. Some other stuff to look at. If you have noise, you can start turning things off. On some of the lower bands, you might want to consider separate antennas for receive and transmit. On 80 meters, there are antennas that work well for transmit, not as well for receive. And then there's antennas that will work better on receive than your transmitting antenna, but you can't transmit through them. Here's something else you can invest in, is a couple of books. Read up on antennas and on setting up your first station. I'm just about out of time here. I'm probably running over, as a matter of fact, so about done. These slides are available on, if you go to the Radio Central Amateur Radio Club website, go into club presentations. This whole slide deck is up there in PDF format, and you can get it. Thanks everybody for listening, and see you on the air. And in the next time slot, in slot 1, Mel, KS2G, is doing an excellent presentation on basics of HF operating. So if I whet your appetite enough that you want to put up an HF station, that's an excellent next forum to go to. Okay, so 7-3 everybody, and enjoy the rest of the day.
Thank you, Neil.
KC2KY.
Nice presentation. There are a couple of questions, and for those that want to write to Neil at his QRZ site, you can send some questions to him. Thank you, Neil. Great job, 73s.
All right, bye.
Okay, hi, Neil. Nice. So I stopped sharing screen. Does that take us out of offline?
Yeah, I think we're offline now.
I think so. Okay.
Just end the webinar, I guess.
Good. Okay. Can you see some of these? Can you see the questions, or is there another way that I can? There's only about 5 questions.
No, I can't anymore. I think something happened with the when you ended the webinar.
Okay, I have them here, and let's see. Maybe there's a way I can capture them. Yeah, there is a way I can capture them. We have time for a couple of minutes before the second one. All right, let me. I'm going to use a sniping tool, and I'm going to see if I can take a few here, which I think I can. Okay.
You're able to just highlight the text and then right click and hit copy.
Yes, exactly. Okay. Okay. And
Kill my camera here. I don't know if people can still
I don't
see.
think.
I think we might still be live.
Okay. All right. Let me just let's see. Okay. Let me just let's just cut out of this completely, and yeah.